is the Meteor Shower project. All right. It's called the Perseids, and if you look at the slide, hopefully you can't see why, it happens round about, you might want to jot this down, August the 12th to 13th. All right. It's not quite the same every year, but generally the maximum of the shower, so if you think of the number of meteors going something like that, the maximum is round about the 12th or the 13th of August. Okay. You may see a really good set of meteors on the 10th of August because the weather's clearer, all right? So any time around that time, there is a particular chance of seeing lots of meteors, okay? All you need to do for this project is to get yourself a star map, okay? You can probably print one off the internet somehow. It's best if it's white with black stars, and that sounds a bit bonkers, but you're going to have to draw on it, so one that's a black image with white stars on it's going to be very difficult to use, okay? Some graphics programs you can just switch the black and the white over and things like that. But if you get a star map like that, what you do is simply go outside, get a deck chair, stare at the sky, and if you see a meteor you think, well, that went just next to the plough there maybe, so that's like that one. And then you see another one like that, one like that, one like that, something like that. And you gradually build them up, okay? With each one you need to note down the time, right, that you saw it, okay? And try and estimate roughly the path that it took. It's a bit tricky at first, but if you stick with it, with an hour or so, you'll get sort of your eye and you'll be able to do it, okay? Now, when you've done that, what you can then do is to follow back the path, do you see? If you get enough meteors, then you can follow them back and they should all point to a point here, which is known for this particular shower as the radiant. Okay? That's really what you're after with this project. If you're thinking, how many meteors do I need? Enough to give you an accurate idea of where the radiant might be. Okay? In which constellation do you think the radiant is for this meteor shower? Yeah, Perseus. You should find the radiant is in the constellation of Perseus. Okay? Later in the year, there is a meteor shower called the Leonids. Anyone like to guess where the radiant is? Leo, all right. Meteor showers take their name from the constellation where the radiant is. That does not mean that all the meteors are in that constellation. So here's Perseus containing the radiant. These other meteors will be a long way from that, all right? But if you were to plot them back, you should be able to find the radiant, okay? As I said, if you want to do Meteor Shower project, this is the one, all right? There are other meteor showers throughout the year, but they are nothing like as good, all right? So if you want to do meteor showers, the Perseids generally has quite good weather that time in August. The other ones generally have times of year where the weather's not so good, and there just aren't as many. The Leonids never produces as many as the Perseids. It's the best meteor shower of the year by miles, and as I said before, if you come back in September hoping to do this, there's no point, because it happens then. It doesn't happen any other time of the year. Okay? The other one people mentioned was meteor shower photography. Now, in theory, notice that's an artist's impression, that's not a real photograph. In theory, this is the perfect lazy person's project. You set your camera up pointing in the general direction of the meteors, you open the shutter, and then you go and watch telly for a few hours, and then you come back, and you should get things flying all over the screen like that. Any meteor that crosses the camera's field of view is just going to record as a thing. Okay? You'll notice that's an artist's impression because actually it's quite difficult to do in some ways. There's a real photograph. You spot the meteors? There's one. There's one. What's happened to the stars though? Blurred.
Well, they move around.
Yeah. The sky goes around once a night, or the earth goes around the other way once a night. Whichever way you want to think about it, the camera and the stars are moving, aren't they? It doesn't really matter who's moving, really. They are moving relative to each other, okay? And for that reason, you end up with what we call trails. The stars are dragged out from being little dots on the film or on the digital sensor. They're dragged out into little trails, okay? It depends a bit what type of lens you're using. This is obviously a wide-angle lens pitch because it's curved at the bottom. But you will end up with star trails, all right? So actually plotting it back to find the radiant, to do that, is actually a bit trickier than in reality, okay? The longer, can I convince you, the longer your camera shutter's open for, the longer the trails. And in fact, if you read the book, read the list, there is a project you can do where you leave it, you don't look for meteors, you just set this photo up and you leave it for about 3 hours. What would it look like after about 3 hours? It's going to get longer lines, aren't you? Okay. What would happen if you left it for 24 hours? In theory, it's annoying, isn't it, because the sun comes up. Forget the sun for a minute. In theory, you should get a full circle. And you can use that, I don't know which one it is, it's one of the B projects. You could actually use that to work out the true rotation period of the Earth. Okay? So for meteor showers, point your camera, open your shutter. We'll talk a bit about after lunch about how you get cameras to do this, because some digital cameras really don't like the idea of holding their shutter open for 5, 6, 7 or 8 hours. Most ordinary, you take a picture with your phone, the shutter is opening the sensor to the light, closing it in probably 100th or 1,000th of a second, all right? Cameras like that don't normally want to open their shutter for 6 hours. They're not really designed for that sort of thing, okay? But if you can do it in theory, it's a nice, easy one.